If I want to check the chat, I can always do that. How do I do it?
Go to the YouTube.
You go to YouTube and
again, and I will tell you later.
No,
not right now.
No, I mean in my home.
Okay, yeah, but not right now because it's the time to teach. Okay. Best for the student taste.
Okay.
Maybe
Okay, let me do the shout out for the students already in. Fresh Nutnicha,
Nadisha. You
Kirapat.
can take off your mask. It's very clear.
Okay. Hat, room for number 30. Parichaya, room for number 27. Chayani, room for number 28.
I think you should put your mask on. It's not good now.
Okay. Tanadon, Moritsara, room 3, number 6, Rachanon, room 1, number 6, Pakom, room 6, number 15, Uxila, Methat, room 4, number 13, Tanakit, room 3, number 15, Pirapat, number 4, room 8, sorry, number 8, Bondi Chai, room 1, number 29, Yicha Kamong, room 1, number 5, Krit, room 3, number 10, Soitong, number 4, room 4, number 14, Ujanathang, room 3, number 27, Pirapol, room 1, number 19, Hanat, room 1, number 20, Viranpat, room 4, number 2, Pimada, room 1, number 14, Kanakon, room 6, number 23. Amon 1, room 4, number 12. Rawipon, room 3, number 20. Tanavi, room 6, number 11. Long Nakatsom, room 4, number 26. Chanita Pon, room 4, number 5. Pakawan, room 6, number 32. Mutnicha, room 6, number 34. Naripon, room 3, number 34. Pasachon, room 3, number 31.
Student
Huh?
the student my teacher, where is he?
Ask where?
Yeah.
Oh, okay.
To the student.
This afternoon, Miss Priscilla is not available because she is at the immigration office doing her visa. I think I told them in the morning already.
He's a new student. Just come.
So I will be taking up this period for science, and next week I will not teach you. You will have 2 periods of math next Friday. Okay. Fimrat, room 1, number 31. Pompatson, room 6, number 8. Saran, room 8, number 50. Itipat, room 4, number 29. Chawakon, room 8, number 14. Tanyapon, room 7, number 42. Janjira, room 5, number 26. Ratinan, room 1, number 34. Samitanan, room 7, number 30. Pongpat, room 4, number 9. Nichapat, room 5, number 38. Amangrat, room 5, number 19. Onrowi, room 6, number 28. Onyawi, room 7, number 10. Hitat, room 5, number 18. Napatson, room 7, number 6. Natakan, room 4, number 18. Kunanya, room 6, number 16. Right. So I'm going to begin the lesson this afternoon on the Doppler effect in light. Now, early this morning, I discussed the topic about the Doppler effect, wherein the movement of light waves depends. The movement of light waves depends on its direction and on the observer. Okay. So, Doppler effect on light. In the morning, we said that sound and light waves, okay, they travel. Except that light wave, they can travel in a vacuum or a space with no matter in it. Now, we're going to relate the Doppler effect on red and blue shift. Okay, let's look at the text. Observers looking at an object that is moving away from them see light that has a longer wavelength than it had when it was emitted. So, objects in space that is moving away from us. Try to remember when you say objects in space, there are celestial bodies that emit light. So when they move away from us or from the observer, that means light waves are expanded, resulting in longer wavelengths and lower frequency. And if we're talking about sound waves, it results in lower pitch. Now, if light waves is approaching, where is that part? Approaching source, light that is shifted to shorter wavelength. Okay? What does shorter wavelength mean? It means that the wavelength of light waves becomes not only shorter, but it also results in higher frequency and higher energy. We call that blue shift. Okay, I will explain later why it's red and why it is blue. So for now, you just try to remember celestial bodies moving away from us. It could be a galaxy or a distant star. When it's moving away from us, it results in a longer wavelength. We call it redshift. If it is moving towards us, resulting in shorter wavelength, we call it blue shift. Okay, let's look at this one. If you remember the word receding this morning, it means that it's moving back to its normal position. So, if an object or a celestial body is moving away from the observer, you will see that the wavelength produced is long. Okay? It results in red waves. Whereas objects that is moving towards the observer, like in this way, it results in shorter wavelength, resulting in blue waves. Now, before I move on, I would like to refresh your memory about what we call the electromagnetic spectrum. So we have the electromagnetic spectrum. The electromagnetic spectrum, it shows us the movement of light waves, okay, or electromagnetic radiation. So you will see here from this part to here, the wavelength is long. And then when we reach this part, we call it the visible light. This is the part of the electromagnetic spectrum that the human eye can see. So this one here is the color of the rainbow. So we have red, orange, yellow, green, blue, indigo, and violet. And then as we move farther from ultraviolet radiation to gamma rays, you will notice that the wavelength becomes shorter. Okay? It becomes shorter. Now, from left to right, this one, the radiation is moving towards what we call the blue shift. Okay? It has something to do with the length of the wavelength. And then here on this side, this part here is what we call the redshift. So if you have, for example, a galaxy that is moving away from the Milky Way, we determine the distance of that galaxy using the length of the wavelength. Okay, the length of the wavelength as it moves away from us. So the farther it moves away from the Milky Way, the longer is the wavelength. And this length of wavelength, we can relate it to what we call the expanding universe. Okay, so this is what scientists are saying, that the farther the galaxy is from our Milky Way, not only galaxies, it could be stars, it means that the wavelength of the light emitted by these galaxies or other celestial bodies is expanding. Okay, so this one is your electromagnetic spectrum, showing us the movement of what we call electromagnetic radiation. Electromagnetic radiation is a form of energy. Okay, let's move on. Now let's have a look at this picture. Now I have here a star, a galaxy, a distant galaxy, okay, and a galaxy that is really far from our Milky Way. So we say now that this star is very near the solar system. And how do we know that? If we take a look at these black lines, in English, we call this one absorption spectrum. Okay, we call it absorption spectrum. This star is near the Milky Way, all right? So we say that this star is quite moving towards our galaxy.
So you will see that this dark line is moving towards the blue part of the spectrum. What does it mean? What does it mean? It means that this celestial body is moving towards our galaxy, and that the wavelength becomes compressed. When it becomes compressed, it results in higher frequency and more energy. Again, please do not forget to relate this concept with your electromagnetic spectrum. So, left of the spectrum, red, long wavelength. When you go to the right, okay, short wavelength, high frequency. Okay? Now, we look at this galaxy now. This galaxy is not quite far from our Milky Way. So you will see here that this galaxy is also on what we call blue shift. Okay? It's very near our Milky Way. It's moving towards our Milky Way. So it results in what we call compression of waves or shorter wavelength. Now, this one is what we call the distant galaxy. Okay? If you remember the lesson this morning, the vocabulary, distant has something to do with how far we are in terms of space or time. So this one is quite far from us. What does this mean? If you look at this absorption spectrum, it's moving towards the red part. Okay, it's moving towards the red part of the electromagnetic spectrum. What does it mean? It means that this distant galaxy is moving far away from our Milky Way. So when that one happens, the light waves emitted by this distant galaxy is expanding. Expansion of light waves result in longer wavelength and lesser frequency. Okay, you can ask some questions through chat. Right, I'm going to give the point this time. Okay, 3 points for this question. I have this galaxy, the one I take. I would like you to tell me or describe to me how this absorption line is moving. Do we call this blue shift or red shift? Okay, again, I repeat the question. I have here a galaxy that is so far from our Milky Way. We said earlier that the farther the galaxies or any other objects in space away from our Milky Way, it is a sign that the universe is expanding. When it expands, the the wavelength also expands, resulting in lesser frequency. So for the light waves that is coming from this galaxy, how would you call that one? Is that red shift or blue shift? Please look at the movement of the black absorption lines. Where are the absorption line moving? Is it towards the blue or the red color? Okay. Okay. CNY Blog Family, room 4, number 12. Correct. The answer is red shift. Okay, can I have some more answer? I have one student who got it correct. CNY Blog Family, red shift. Correct. We run pot, room 4, number 20. Correct. The answer is red shift. Students, all you have to do is to follow the black absorption line. It's telling you whether it is going blue or red shift. Okay. Chanita Pon, correct. Room 4, number 5, correct. It's red shift. Soitong, room 4, number 14, red shift, correct. Bondi Chai, room 1, number 29, correct. Red shift. Who are you? Room 1, number 10, correct, red shift. Ploy Mika,
Room 4, number 26, redshift, correct. PT, room 2, number 17, redshift. Pimrat, room 1, number 31, redshift, correct. Setowood, room 4, number 23, redshift, correct. Any other answers? Okay. Patcharapon, room 7, number 40, redshift, correct. Okay, any more answers? No more? All right. So that is the correct answer to the question. So I would like to summarize this part. We say that the universe is expanding. Galaxies are moving away from our Milky Way because the light emitted by these galaxies, the light waves emitted by these galaxies is expanding. When it expands, it results in longer wavelength and lesser frequency. Okay, I have more correct answers here. Natapat, redshift. Anawin, redshift. Itipat, redshift. Tin, redshift. Tin, room 2, number 23. Okay, students, I would like to repeat again that I would advise you to participate more in chat because I'm going to get the points for listening skills in this chat. And next week, you are going to receive your first worksheet from me. The worksheet is about the galaxies. If you remember, for students in rooms 1 to 5 and rooms 7 to 8, before the school closed, I asked you to give me a work about the Big Bang Theory. You still have to submit that when you come back to school. Okay, I need that work for points. So I hope by this time you've done that work already. Okay, more correct answers. Sutipong Pintakul. Room 4, number 4. Mind, redshift, correct. Room 2, number 16. Okay. Chem, room 3, number 20, correct. Okay, no more. So if you have any questions about this topic, you can send me a chat and I will go back to explain it again. Okay, I have another answer here, room 7, number 6. I have redshift. Now, I would like you to look at this text on my PowerPoint. I have another answer here, room 7, redshift. Room 7, number 6, pi. Room 3, number 11, redshift. Okay, this is an explanation of the picture previously shown. The picture shows a galactic star, okay, that is the first one below, a nearby galaxy, a medium distant galaxy, and a distant galaxy. The distant galaxy is the one that looks like a dot. The spectrum shows the dark absorption lines. What is the use of these dark absorption lines? It is used to identify the chemical elements in distant stars. So distant stars emits elements that can be detected using the absorption lines. We are not going to go deep into those topics because that one is a topic in your physics class. The pattern of absorption lines shifts to the red as the galaxies gain fainter, okay? In the vocabulary this morning, who can give me the answer to this question? Galaxies get fainter. What is the meaning of the term faint? Okay, this is one of the vocabulary this morning. I got another answer, room 4, number 35, redshift. Okay. Okay, I will give 3 points for this question to anybody who can answer. What is the meaning of the term faint? Faint. F-I-N-T. If you remember, I showed you 3 colors, and in the middle of the color, it looks faint. Okay, I got an answer here, Soitong.
So Itong, yes, it's something to do with brightness. Can you clarify some more in terms of brightness? Does it mean more bright or less bright? So Itong, can you give me your answer? Less or more bright? Okay, Tin, your answer is correct. Barely perceptible. You get the point. So Itong, I'm going to look for your answer. Less or more bright? Okay, you will get 3 points. What is the answer? Chanita Pon, correct. Lacking brightness. Room 4, number 5. Suti Fong, lacking brightness, correct. Room 4, number 4. Soy Tong, okay, your answer is correct. Less bright. Okay, so you have, Soy Tong is room 4, number 14. Students, I'm going to go back to this online class and I will check the students who gave me the correct answer and they will be the one who will get the points. So when you come back to school, you've earned the points already. Okay? Ploymika, lacking brightness. Yes, correct. Ploymika, what is your room? For number 26. Natapat, room 8, number 54. Correct? Natapat. Anawin, correct? Less bright. Room 7, number 33. Wiranpak, lacking brightness. Room 4, number 20. Sirawut, correct? Lacking brightness. Kim, less bright, correct. You can use different adjectives to tell me that it is less bright. It does not necessarily mean that you can use only one, like less bright or lacking brightness. You can use any other type of adjective to describe. Lacking brightness, Pi, correct. CNY blood family, room 4, number 12, correct. Lacking brightness, who is this one? Pimrat, room 1, number 31. Pimada, correct. Less bright, room 1, number 14. Pacharapon, lacking brightness, room 7, number 40. Sirapap, room 4, number 25, lacking brightness, correct. Mimiu, your message was retracted. Room 1, number 10, lacking brightness, yes. Room 1, number 29, Wondi Chai, lacking brightness. Yes, that is the correct answer. Right. Next question, another 3 points. If you are observant enough in the picture previously shown, there are numbers at the top. What do those numbers represent? If you will see here, the numbers above and below the spectra are measured wavelengths in nanometer. So this is the unit. What does this unit represent? What does this unit represent? Okay, question. Anybody, can you give me the answer? There are numbers on top and below of the picture shown earlier. And the unit of these numbers is in nanometers. Nanometers represent what? Everybody, I want you to focus on this sentence because the answer is here. Okay, I'm going to wait for your answer. Nanometer represent, the unit nanometers represents what? Anyone? The answer is here in the sentence that I picked. The numbers above and below the spectra are measured in are the measured wavelengths in nanometers. Nati, no, it is not light frequency. 10, it is not spectrum. Focus again on the sentence, the last sentence on this slide. The answer is there. Okay, I got the correct answer. CNY blood family, room 4, number 12. The answer is wavelength. Okay, this is the one. So wavelengths is expressed in nm or nanometers. Okay. So Tin, wavelength, correct. Amy, wavelength. Room 1, number 10, wavelength. Okay, let's move on. So I will emphasize this time on redshift. Nung napatson, correct? Room 4, number 26. Number 6, room number 7, wavelength, correct? Room 1, number 25, not Nari, correct? Kim, room 3, number 20, wavelength. Sarah Wood, room 4, number 23, correct? Natapat, room 8, number 54, wavelength. Rich Chalk, room 1, number 22, wavelength. Anawin, room 7, number 33, wavelength, correct? Now, an example of Doppler effect is redshift and blueshift. Okay, let's focus on redshift. An object moves away from us. Sound or light waves emitted by an object are stretched out, which makes them have a lower pitch and moves them toward the red end of the electromagnetic spectrum. Okay, question. If an object moves away from us, let's say for example a galaxy, what happens to the light waves emitted by that galaxy? You can look at the text on this slide. Again, I repeat the question. If a celestial object, like for example a galaxy, moves away from our Milky Way, what happens to the light waves of that galaxy that is moving away from us? The answer is not wavelength. Tim, you've got it correct. Room 2, number 23, the answer is stretch out. Okay, students, this is the reading part of this lesson. Pay attention to the reading, the short passage given on the slide. Okay, that is correct. It's stretched out. When it's stretched out, okay, next question. Bondi Chai, correct. Room 1, number 29. CNY, blood family, correct. Stretch out, Natapat, stretch out, correct. Nong Napatson, correct. Soitong, correct. This one has no name, it's in Thai. Room 7, number 6, correct. Room 1, number 10, correct. Bailey. Room 7, number 40, correct. Kim, correct. Room 3, number 20. Pimada, room 1, number 14, correct. Viranpat, correct. Amy, correct. Pimrat, correct. Chanita Pon, correct. Seta Wood, correct. Anawin, correct. Okay. Next question. Focus again on this short passage. If the waves, the light waves are stretched out, what happens to the frequency of the waves? If the light waves are stretched out, what happens to the frequency of the light waves? Does it become less or more? Okay. Does it become less or more? My question. No, not pitch. I'm asking for the frequency. No, not pitch. What happens to the frequency of the waves if the wavelength is stretched out? Guys, do not answer pitch. I'm asking for the frequency. Does the frequency become less or more? C and Y. The answer is not it. Bondi Chai. Correct. You got the correct answer. The frequency is less. It looks like this. Okay, look. What is the difference between this and this? Okay, look at the wavelength long. So here we say frequency is less. And here, frequency is more. Okay, you can see that there are more waves here, right? 1, 2, 3, 4. Okay, so the higher the frequency, the more waves there are. Okay, now if it's stretched out so much, you have less waves. So you have less frequency and less pitch. The ones who answered before the pitch is correct, but I'm not asking for the pitch, I'm asking for the frequency. Okay, correct. Let me see. Pimada, pacharapon. Less, correct. Pimada, correct. Room 7, number 6, correct. Room 1, number 10, correct. Chanitapon, correct. No, napatson, correct. Tin, correct. Kem, correct. Setawut, correct. Pochara, correct. Anawin, correct. Natapat, correct. Less frequency. Sirapap, correct. Viranpat, correct. Okay. So let's move on now. Redshift is an indication that the universe is expanding. So according to the findings of the scientists, more and more celestial bodies like galaxies is moving away from our Milky Way. Okay. Let's move on now to blue shift. Okay, I will ask a question about blue shift. Blue shift is any decrease in wavelength. Take note, decrease in wavelength with a corresponding increase in frequency of an electromagnetic wave. Okay, question. In blue shift, where or which part of the electromagnetic spectrum are the waves moving? Is it toward red or blue? What is your answer? A blue shift is any decrease in wavelength. Decrease in wavelength. Okay, students again. I cannot write here. Look. Okay, look. Where is decrease in wavelength? A or B? Students? I got the correct answer already. The answer is towards the blue part of the electromagnetic spectrum. Okay, the following students got it correct. Bondi Chai, Pesawat. No, not less. Soitong, CNY, Sutipong, Richot, Pisawat, Anawin. Nong Napatson, Chanitapon, Amy, Kim, Natapat. Number 6, room 7, correct. Pimrat, Pochara, Pimada. Ruchanatan, Nati, Setawut, Natachet. No answer. Number 10, room 1, correct. Blue. Tin, correct. Pacharapon, correct. Viranpat, correct. Okay, so the students earn the points. Sirapap, correct. Room 4, number 25. Right. So it moves towards the blue side of the electromagnetic spectrum. Okay, next question. If it moves on the side, the blue side of the electromagnetic spectrum, what happens to its frequency? Students, focus on this one. What happens to the frequency? You can answer either increasing or decreasing. In blue shift, the object moves closer to the observer. or like a galaxy moves closer to our Milky Way, what happens to the frequency? The answer is either increase or decrease. Okay, Soy Tong, what is your answer? Okay, correct, increasing. Bondi Chai, correct, increasing. C. Rapap, no answer. C and Y, correct. Natapat, correct. Pacharapon, correct. Chanita Pon, correct. Winrapat, correct. Pisawat, correct. Pimrat, correct. And room 1, number 10, correct. Kem, Pimada, correct. So frequency increases. Anawin, Setawot, correct. Rinrada, correct. Rinrada, room 3, number 18. Sutipong, correct. Nong Napatson, correct. Sirapap, correct. Okay, let's move on. Okay, I have 9 minutes left. Okay, let's look at this picture. We have a police car. Okay, for the police car, we are talking here about what kind of waves. What kind of waves come from the galaxy? Anyone? And what kind of wave come from the car? Anybody? 2 points for each correct answer. What kind of waves comes from the car? And that kind of wave that comes from the galaxy. This morning I mentioned 2 only, if you remember. The first type of wave, it can travel to a vacuum, and the second type of wave, it can travel to 3 mediums, solid, liquid, and gas. So if you're talking about the police car or ambulance, what type of wave does it release? Anyone? Come on, Dichay, no, not galaxy. The police car, you focus on this one. What kind of wave? Do you remember this morning? Okay, Nati, you got it correct. Light and sound wave. So if you're talking about the galaxy, okay, you get the point for this one. The galaxy emits light wave, and the car emits sound waves. Very good, Nati. So there's another answer here, not a pot. Car radio waves. Radio wave, sound waves, light wave, Anawin, correct. C and Y, block family, correct. Right. So we can relate this example of the police car with that of the light waves coming from a galaxy. So you will notice here, if you remember this analogy, I introduced this earlier, if the police car is approaching the observer, you will see that the frequency of the sound wave increases, and when it moves away from this particular observer, the frequency of the sound waves decreases. Now let us relate this one to that of the galaxy. So you have here a galaxy moving towards our Milky Way. Okay, how will you describe the wavelength of this galaxy moving towards the Milky Way? How will you describe the wavelength? Is it more, shorter, or longer? Anyone? How will you describe the wavelength of this galaxy approaching the Milky Way? Is it short or long? Students, look at the picture. Okay, very good. C and Y, shorter, correct. From room 4, number 12. That is the correct answer. It becomes shorter. So itong, okay, got it correct. Okay, let's move on. Now, I would like to introduce to you Edwin Hubble. Edwin Hubble is an American astronomer. When you say astronomer, This is a scientist who study about the universe. Okay, everything about the universe. And the Hubble Space Telescope was named after him. He is the first one to describe the redshift phenomenon. And he related it to what we call the expanding universe. Okay? This is Edwin Hubble. I just edited the picture so it looks better when you look at it. Right. The galaxies are moving away from Earth because the fabric of space itself is expanding. When galaxies themselves are on the move, the Andromeda Galaxy and the Milky Way, for example, are on collision course. There is an overall phenomenon of redshift happening as the universe gets bigger. Students, I do not know if you've heard about this before. Andromeda Galaxy. This is our satellite galaxy. It's a very small galaxy, very close to the Milky Way. Okay, I have here the animation. You can see, I cannot remember how many billion of years it will happen, but the Andromeda Galaxy, our neighboring galaxy, will collide with our Milky Way, and it's going to produce another type of galaxy which we call elliptical galaxy, if you remember the lesson last week. Okay, so we have spiral, elliptical, and irregular. So the collision of two galaxies, it will normally result in what we call the elliptical galaxy. Okay, this one is a picture showing the Andromeda. This one is Andromeda Galaxy, and this one is our Milky Way. Okay. Now, I think my time is up. Now, I'm going to continue this lesson next time. Okay, we will do more of the redshift video, and then next week, I don't think it's going to be next week. After next week,